Oh, thank you for the few number of people who came. I think I should stop doing these kind of talks at, sponsored talks, especially the ones during lunch. Yeah, I'll make a note of that. I think this is my second time doing this same talk on a Java conference, and the turnout has been quite similar. And I did the same talks in JavaScript conferences. The turnout was great. So I see the problem. Cool. Anyway, for those of you here, thank you. Thank you for the interest. I'm going to talk about AI security today. I mean, you have to talk about something related to AI. You need to slap AI somewhere in there. But this is going to be actually about AI security. And a little bit about me. I'm Deepu Shashidharan, Java champion, developer advocate, huge open source. I have done quite a lot of open source work in the past, still do. That's about me. I don't do a lot of Java these days because I'm doing a lot of AI security stuff nowadays, and it's mostly on the JavaScript Python side of things. I'm also a polyglot developer, so it's not a huge issue for me, but I see the issue when I'm at a Java conference presenting this. So, cool. The current state of AI security. How many of you have vibe coded here? Oh, cool. I do believe that for folks like me in the cybersecurity side of things, this is a great time. It's going to be a lot more vulnerabilities coming out. There's going to be a lot more security issues coming out with all the vibe coding and all the AI-generated code. So I think my job is quite secure for at least a while with everything that is going on. There was a recent report about the increase in vulnerabilities and security issues in code overall. And you wonder, what has changed from the same time, maybe last year. So what is the state of AI security currently? So OWASP, like everything else, also tracks vulnerabilities that has to do with AI or LLMs. So these are the LLM top 10. So you have your prompt injection, the topmost issue when it comes to AI security. You have sensitive information disclosure. That's your LLM or the AI system leaking confidential information. You have supply chain attacks, like everything else. You have data and model poisoning at the training side of things. You have improper output handling. That's when you use an LLM to generate something, let's say code or whatever, and you don't do sanitation on the output. And if you blindly just run it or blindly let the agent run the code, that's when improper output handling and related issues prop up. Then you have excessive agency. That's when your LLM or AI agent or AI application have unlimited access to stuff or unrestricted scopes, unrestricted permissions, stuff like that. That's when your coding assistant or AI agent ends up deleting your database or ends up nuking your file system and stuff like that. Then we have system prompt leakage, again more of a LLM side of thing, but also if you are, if you have your own system prompts on top of the LLM system prompt in your application, that's something that could happen as well. Then we have vector embedding weaknesses. This is more like database-related vulnerabilities. Similar to normal databases, you also have issues with vector databases as well. Of course, there is misinformation, which is a huge issue. Then we have unbound consumption. That's when you run out of resources because of running an AI agent or an LLM. Imagine you have an application that uses an LLM for stuff, and you have, let's say, credits of whatever, dollar or euro. You have certain credits, and let's say I trick the LLM to go into a loop utilizing all of your resources. It can be monetary resource. It can be utilizing your infrastructure resources, your bandwidth, or your CPU, GPU, all that stuff. So these are the top 10 when it comes to AI-related systems or AI systems. And out of these, some, for example, prompt injection, supply chain attacks, these may not be exactly in an end developer's hand. Like if you are building AI applications or AI agents, these might not be in your hand or in your control most of the time. But the ones that I have highlighted here, they are often in your control. So you can safeguard against sensitive information disclosure. You can do something about improper output handling. You can do something about excessive agency, and so on. So these are the things that a developer can control and should control in their own system to ensure that on top of whatever the provider of the LLM or the agentic framework or whatever they provide, these are the things that you need to ensure that you secure as well. So today I'm going to talk about only two of these because covering all of those would take more time. So I'm just going to cover sensitive information disclosure and excessive agency. So sensitive information disclosure, it's so LLMs are great, right? Like they are almost like teenagers. They have so much power and energy, but probably not directed towards the best things. So and when you use LLMs and when you start feeding it a lot of data, inadvertently at some point this data is going to end up in someone else's screen. You may not have intended that, but that's the nature of LLM. The more they learn, the more they are trained on. At some point, regardless of the guardrails you put in, it's going to end up in someone's screen. So what do? You control it at the source. That's what we need to do. So let's see how that would look like. So authorizations are an obvious solution. Like how we do authorizations for humans, we also have to do authorizations for the data, authorizations for the AI agents, and so on. So how can we do authorizations? Can we do role-based access control to control what goes into the AI system as data? Maybe if your data is like let's say you have very limited data and you know exactly how the role systems or the permission needs to be structured, yeah, maybe. But most often it's not practical, because there are some security challenges when it comes to trying to do RBAC on a data-intensive system, that something like a RAG system, where you're feeding tons of data for the agent to analyze and give you relevant results. So security challenge is often on RAG systems. The context is quite dynamic. You would have complex relationship between data. So let's say you have a CMS connected to a RAG system. So your agent or application gets data from the CMS to provide relevant answers. And this particular CMS might have tons of users with different access controls. The user access might be structured based on organization and so on. So there can be complex relationship between these documents. And you often would need granular control. Let's say you are a HR, you need access to all the employees in your org. And if you're a manager, you need access to the data of the employees that report to you. And if you're an employee, you need access to your own data. So how do we segregate this? How do we granularize this? RBAC doesn't scale for these kind of scenarios. And finally, performance requirements. Because of the nature of RAG systems, you often, even though like LLMs, we don't expect that kind of performance from LLMs, but when you have RAG systems and when you want to do these kind of permission checks on like tons of data or tons of documents, this could add up and it would make your overall system more sluggish than it currently is. So how can we solve this? So that is where relationship-based access control or fine-grained access control comes into the picture. So fine-grained access control is nothing new. It has been around for a while. For example, if you have been using, let's say, Google Drive, it does fine-grained access control. Google has a system called Zanzibar that does fine-grained access control. There are different systems out there. And at Auth2, we built a system for this. So it's called OpenFGA. It's a CNCF project. So it lets you do relationship-based or fine-grained access control. So you can build relationship models between your data, and you can assign users to this relationship model, and you can kind of build a relationship-based access control policies for whatever data sets you have with OpenFGA. So you also provide this as a product, of course. With OpenFGA, how does it work? So you define something called an FGA store or an authorization store. So this is a store for a particular application, for example. And an authorization, a store would contain an authorization model. A model is where you define who has access to what, or what kind of hierarchy is present in the org that you are doing this for, or the application that you are doing this for. So you define a model. Then you define the actual relationship. So this is the model, and this is the actual relation. User A has this relation to this particular data. So you define those relationships. And then you have certain endpoints that you can use to check the relationship of a particular user, or get an object and check who has access to the object, vice versa, and so on. So that's how FGA works in short. So if you want to picturize this, so let's say you have documents, you have a bunch of documents, let's say you have a CMS, existing CMS, or you're building a new CMS, doesn't matter. You have a lot of documents, you create chunks out of these documents, and you create embeddings for these documents. Then you put them in your vector store, right? Then a user comes up and asks for a particular question. In this particular example, they ask for show me forecast for a company called Zico. So what happens? Again, the question gets converted into an embedding. You search your vector store for the a similarity search on the vector store for similar embeddings. You get all the document chunks that matches this particular query. So you get all document that has anything to do with forecast and Zico in this case. But if you feed these documents directly to LLM, of course, in most cases, the LLM will figure out what to filter out and give you an okayish answer for the question. But what happens is that data, all this data went into the LLM, right? The user might not be having access to this data, all this data, but it still went into the LLM, and inadvertently, at some point, that might end up on someone's screen who should not be able to see those data. So instead of loading these documents directly to this is what people usually do. You get these documents, you feed it to the LLM. That's how RAG systems work. But what you do here, before you pass it to the LLM, you send it through another filter. So let's call it FGA filter or FGA retriever, depending on the framework that you use. So what you do, in this particular filter, you look at the documents. Let's say you have 30 documents. You look at the documents, you check the FGA database for the policies for these documents, and you see if this particular user has access to these documents. If not, you filter them out. So what comes out of the filter is documents that this user has permissions to view. So the LLM only gets those documents, so there is no chance of unauthorized data being sent to the LLM, which might end up in someone else's screen. So this is how you can secure a RAG system using a system like FGA. I mean, the methodology need not be just for FGA. You can do the same with any sort of authorization mechanism here. The point is you put your authorization in between the data and the LLM, and you remove the logic and control outside of the LLM, so that LLM doesn't have any way to modify anything there. So if you're designing this as a tool, you do the logic within your tool, because LLM can only trigger the tool and get an output. It cannot go and change the logic of the tool, or it cannot, it cannot say what the tool should do. So that's why we are relying on tools more and more, right? It's more secure, because LLM won't have access to or won't have much control over the tool except for what you allow in the API. So do all this security stuff within your tool. So this is how an FGA model would look like. So this is, for example, this is a fictional model where you have a user, where you have domain and documents, and you can kind of define relationship between this. So let's say user NA has editor relationship with a document called new roadmap, right? So it's a very simple model. You can have very complex models, hierarchical models. You can even model ABAC, RBAC using FGA. So FGA is like too flexible, I would say. So you can model any other kind of authorization mechanism using FGA. But FGA could also be an overkill if you don't have the scale and requirement. If you have a very simple database with limited number of documents, probably RBAC or ABAC or even a combination might be a lighter lift than FGA, because FGA requires an investment upfront in order to set this up, because defining the model is fine. You have to define the model. You have to define relationship between objects. If it is an existing system, that could be a bit of work. So it might be an overkill for very simple systems. But if you have the scale, especially for enterprises and big companies who have lots of data, then this might be a worthwhile investment. Yeah. I am supposed to go over that. I completely forgot. Should have clicked. So this is how code-wise it would look like. This is JavaScript code. I don't have. We built this for JavaScript and Python first. We don't have Java SDKs yet. It's in the pipeline. So I only have JavaScript code to show for now. But for example, this is a LangChain tool, and this is how it look like within the tool. Let's say you will create a filter. You can define the query within the filter on what to look for. So in this particular filter, we are going to look for users. We are going to see if the user who's using that particular session can view relationship with the document that is being retrieved. So you retrieve all the documents. So in the next step, you find all relevant content for the user's query. Then you pass those retrieved content to the filter. The filter takes out anything that the user is not supposed to see and provides the relevant context back from the tool. And then the LLM wouldn't even know what's happening here. It would just get the data. It will think, oh, this is the data for the query, and it will go along processing that. So let's look into excessive agency. So excessive agency is a very broad term. It has a lot of assets. You can technically, whenever there is a scope beyond what is required, you can call it an excessive agency issue. This is where zero trust mechanisms and zero trust authorizations and all that comes into the picture. So there are few key security challenges related to excessive agency, specifically for AI systems. One is tool access. Who has access to what tools, or when should certain tools be accessed? Next, calling third-party or your own APIs. How do you secure that when you're calling APIs from within an AI system or from within AI tools? And how do you ensure that humans are in the loop for very sensitive stuff or very critical stuff? How do you ensure that the AI doesn't have a power to do whatever it wants, and critical actions can be, a human can be in the loop for critical actions? So how do we do this? So let's go one by one. So for tool access, there are multiple options. Number one would be zero trust. Like, we treat everything the same way we treat humans. Like, we don't trust the AI by default. We don't trust the tools by default. We don't give the agent any tools by default. Zero trust, right? Let's say how we can do those. Like, there are a few ways. One, we can do it with standard RBAC for simpler stuff. Let's say in most of systems, you would have some sort of identity mechanism. Let's say you're using an OAuth2 based identity provider like Keycloak or Okta, Auth0, whatever. Or you have your own implementation of user identity. Regardless of that, you might have some sort of roles and permission system. So use that within the tools. For any tool, you can always use those permissions, like how you would do for your standard functions and how you would do for your standard logic. You can use the same thing within the AI tools to see if the current user in session has access to run this tool, or the agent, the version of the agent that you're running, has access to run this particular tools. Then you check that within, again, you have to do this within the tool so that there is no way that the agent would accidentally run something, right? Because you cannot trust the LLM to always make the right decision. It might make the right decisions 80% of the time, but the remaining 20% of the time, it might make mistakes. So you don't give this control to the LLM. You take this control and you put this control within your tool, within your code where you have control, and you control that based on your role mechanism, permission system, based on your IDP. So here it uses auth0 to get the session, get user's role, and checks for the relevant permission in the roles, and executes or does not execute the tool based on that. So this is for a very simple use case. Let's say we want to do, okay, again, I keep forgetting to do that. I should just remove those. I'm never doing those anyway. So next would be, let's say we have a tool, and what if we want to do, we want to go even further, what if we want to do authorizations even more granular? Let's say you have tools, but you want to control what the tool can do based on user context. Let's say this particular tool, which can buy stock, and let's say you want to control who can buy what stock. So let's say user A can buy Google, Microsoft, and NVIDIA, but let's say user B can only buy NVIDIA. So how do you control this using the same tool? So again, you can use something like OpenFGA, any system that provides fine-grained access control, you can use that system. And then within the tool, like how you did for RBAC, within the tool, you dynamically check for the user's permission for the particular action. In this case, we are checking if the user has a relation called can buy for a particular asset. And then you execute or don't execute the system based on that. So we can use these kind of authorization mechanisms to control tool access and to ensure that the LLM doesn't have excessive agency when it comes to executing any kind of action on behalf of us. Again, I forgot. So calling API. So that was about tool access. Another common use case, especially for any serious kind of AI implementation, you'd always want to call some APIs to do something. Let's say you have an AI assistant that needs to talk to, let's say, Gmail and your calendar to plan vacations for you. Let's say this assistant can plan vacations for you, so it might have to send emails on behalf of you. It might want to go check your calendar for free times and make appointments for you, reschedule appointments if required, all sort of stuff. It might want to get your permissions before making flight reservations or all this kind of stuff. Let's keep that as an example. So how do we make sure this particular agent, which can do all these actions, does it in a secure way so that it doesn't accidentally, let's say, go delete your emails or go do stuff that you don't want it to, or doesn't do stuff without your explicit permission? So one use case would be calling your own APIs. Let's say you have two systems. One system is your AI application, and you have other system, which is your existing APIs that gives whatever API, whatever data you have in your particular use case. Let's say this AI agent has to access this APIs that you have. Since it is your own API, and if you're using an IDP that is OAuth2 based, you can call this using JWT tokens, access tokens. So within your tool, you can get your user session, you can get access tokens for your current user, and you can pass that access tokens to call your own APIs. Of course, you will model your own API with audience, your API's audience. You will model that as a client so that you can, cross-access. You can send access tokens across, validate them and all. So that's quite simple. This approach would be quite simple for first-party API calling. You just use your own access tokens. You call them like any other API, but you do it from within a tool so that the LLM can get data based on the current logged-in user and based on their permissions. So the LLM would only be able to access whatever the user has permission to access, whatever the APIs the user is assigned to, or whatever the API the user can see. So again, we are restricting the LLM's scope without giving it too much control. So instead of giving the LLM a blanket access to the entire API with like a API key, you are relying on the user's access control. So the LLM does it on behalf of the user. So then would be third-party APIs. So third-party APIs like the example that I was mentioning. So if you want to access Gmail, Google usually expects you to use OAuth2 when you call the APIs. So you would have to create a Google client, you would have to integrate with that, you would have to do token exchanges and all that stuff. But let's say you already have a system that in place. Your application is already secured with something like Keycloak or Auth0. So you already have an IDP. You already have an IDP that is giving you tokens for access. You're managing your authorizations and everything. Why do you have to also integrate with another IDP and do all this for Google? Then you might want to do it with Slack. So you keep adding more IDPs to your system. You don't have to do that. A lot of identity providers support federation. So we can use something like that. For example, OAuth2 federation is when an identity provider can do token exchange with another service provider that also has supports OAuth. on behalf of the end user, so that the end user can get tokens from your own IDP and use those tokens to get data from another service provider without having to do the entire handshake mechanism, without having to configure the entire system as an IDP. And advantage of this mechanism is that your accounts can be connected. You can link these accounts together. So if you have an Auth0 account, and if you want to use Google, you can link the Google account together with Auth0 and make it one identity. And you can do everything via Auth0, for example. So at Auth0, we call this feature token vault. So basically what it does is Auth0 kind of acts as a broker for you. So it can connect to any other IDP that supports OAuth2, and which can be a service provider. And then your AA agent can just ask Auth0, hey, get me access tokens for Google, or get me access tokens for Slack, get me an access token for GitHub. So it is going to give you access token, same way that you would ask Auth0, hey, get me an access token for this particular user. So it makes it easy, it makes it more secure, and it also makes it more scalable. And another advantage of going this route is you put the control at the end user's hand. The end user decides what permissions to give. You as a developer will not be setting up an API key with fixed scopes and using that API to make API key to make the API, third-party API calls. And here, the responsibility of managing the scopes and making sure the user's data doesn't get, unwanted data doesn't get in, all that falls to you. But following this approach, you are offloading all that to the IDP and to the OAuth2 mechanisms, which might already be in place. And when for the end user, they would already have their Google account configured however they want. So they can say that, OK, I give this application permission to read my emails, but not to write. So they have absolute control. So let's see how it would look in an application. So for example, let's say you have an AI application, you have your agent running, which connects to the LLM, and you have tools. Let's say you have a Gmail draft tool, Gmail search tool, and all other tools. These tools would have to call the Gmail APIs. Usually, these days, like normally, how people would do this is with API keys. But as I said, it again doesn't solve XSE agency, because API keys often have very wide scope. They cannot be granular. It's very hard for for you to define granular permissions for API keys. You would have to kind of give blanket permissions that might be applicable for a wide range of users. So they're not that secure. They're not scalable. They're also mostly long-lived tokens, so not that secure in the end. So how we solve that with an IDP like Auth0 or any other IDP that supports OAuth federation. So basically, you ask the IDP to get tokens on your behalf from these systems. And these are going to be just access tokens, short-lived access tokens. Then you do the API calls using the access token. They expire after a while. So next time you try, you get a new token. So there is no issues of your tokens being misused, or if your token gets leaked, nobody's going to take that token and be able to access all your Gmail data and stuff like that. So this is less worrying for the end user, because they don't have to trust you to manage everything, because the control is in their hand. Most of them are used to the OAuth2 flow of signing in with Google or signing in with Facebook or whatever. So they continue to use the same mechanism. I'll show you a demo after this. Code-wise, how it could look. With Auth0, you would define a connection. So for example, I'm defining a connection to Google. You can define multiple connections, even for the same. So let's say you can define, so this is called with Google connection. You can define another one called with Google Calendar, another one with Google Gmail read-only, with Google Gmail write, stuff like that. So any number of connections, or with Slack, with GitHub, whatever, any number of connections. Then you use those connections and wrap your tools with that connection. And within the tool, you can just say get access token, and you will get a Google access token with that particular scope of calendar events. So this access token will only have access to read calendar events, nothing else. So you don't have to worry about your API key being misused, because it only has access to one particular thing, which the user explicitly agreed to. So then you get the access token, you call the calendar APIs, and you get response from the calendar API. So the chance of misuse is very low here. Again, this goes with the zero trust principles and the giving them the bare minimum. So the issue of excessive agency is highly reduced. So the next in the picture, the next item in excessive agency is human in the loop. How do we ensure that people are in the loop for sensitive actions or critical stuff? How do we do that? Right now, most AI applications, AI agents, there's not a lot of human in the loop going on. You ask the agent to do certain stuff, it does certain stuff. The only closest thing is in your AI agents, coding assistants. When you ask it to do something like, let's delete a folder or something, some of them would ask you, are you sure? Stuff like that. But how do you ensure that this happens for all your tools, or at least for the critical tools, and it is not in the hand of the LLM to decide when to ask that question? Because right now, most implementations, the asking that question is in the LLM's hand. It decides when to ask that question. That's why there was a recent incident which was viral about coding assistant deleting someone's database, even though they explicitly told it not to. That's because the control was with the LLM. So it doesn't care what you say. It's non-deterministic. It's just going to guess the next word and so on, right? So it doesn't care. It might execute that action even if you say don't. So take that away from the LLM. Don't give LLM the control or to decide when to do this. Put it inside your tools. So your tools decide when to ask for human approval and stuff like that with standard if-else or whatever logic, right? So which is more deterministic. So how can we do human-in-the-loop interactions? So there is a new standard called CIBA. It stands for Client-Initiated Back-Channel Authorizations. This standard was meant for headless systems. So the client-initiated here stands for the actual client. So the authorization is not initiated by you. The system initiates an authorization and asks you to authorize. So the client initiates it. It was meant for systems like support agent, support systems, and like telecalling kind of systems where someone else can trigger the authorization flow, you approve, and they get an access token to do whatever with it. So it was meant for that, but this is also ideal for AI agents because AI agents often are autonomous and running in the background. They are headless, and if you give the AI agent a mechanism to trigger an authorization request, which you have to approve. So again, that part is fine for it to trigger, right? Because in the end, the control is with you. You either agree or deny the request, but the agent can trigger the request. So we use CIBA for asynchronous authorizations because again, CIBA is asynchronous by nature. It doesn't wait for you to do the authorization. It sends you an authorization, goes and does whatever. I mean, the logic can proceed doing whatever it wants. And once you finish the authorization, it will just continue from there. So how it would work in an AI system would be the AI agent will request authorization, let's say to buy stock. So it is going to request your authorization server, like Keycloak or Auth0, and the authorization server sends a notification to the end user. Again, CIBA may not be implemented by every identity provider. It's quite new. We implemented it at Auth0. I don't know if Keycloak does it. I'm not sure about that. So the sending notification can be a push notification, can be an SMS, can be email, depending on your IDP and configurations. But regardless, user gets a notification. As a user, you will approve or deny the request. Once that happens, the authorization server will grant or deny the request. And once granted, the AI agent can get an access token on your behalf, with which it might be able to call APIs on your behalf, or it might be able to exchange that for a third-party token or whatever. Code-wise, again, bear with me for the JavaScript code. A bit similar to how we saw the third-party tool calling. You define a block that creates this asynchronous authorization setup. You kind of link the user in that setup. You can put in messages like a binding message on what you want to show when the request comes to the user. And you can assign scopes that needs to be present. You can assign the audience for the specific APIs if you want. And you can also define the logic of what happens when the request is denied. And then you wrap your tool with that function. And within the tool, you can simply get a CBAR credential and use the access token from that. And the tool will only be executed if you approve the request. If you deny the request, the tool doesn't get executed. So whatever is the logic within the tool doesn't get executed, and the LLM is going to say that, yeah, could not complete the request, or whatever is your error handling mechanism. So let's see a small demo. Okay. Okay, so I have a chatbot. It's called Assistant Zero. You can get if you are interested to check out the code, you can scan the QR code and check out the repo. It has multiple implementations. Right now, only Python and JavaScript, but multiple frameworks and stuff, but might give you an idea of how these things are configured in practice with a chatbot. So I'm going to log in. So let's say I'm going to log in with my Google account. So I have logged in, and now I can ask the agent for something like, probably not a great idea to get my emails. Hope it's nothing bad. Hope it's not, let's see, forums should be safe. So it's going to, so we call this flow, we call this step-up authorizations, because you already authorized to the application. You logged into the application, but when you logged in, you only gave the application permission to read your email. So now we are stepping it up. So on a need basis, you can do this. You can configure this to be one time. So if you want all this to happen, first time you log in, you can set it up that way. But if you want to be very secure, you do step-up authorization. So this is step-up authorization now. So I'm going to authorize it further. So I'm going to give it, so it is going to, again, ask me to log in. So this is a developer setup, so I have to do a few extra setup. But in production, you won't see all these screens. So it is going to ask me to allow access to reading Gmail. So it already has access to my email and that kind of stuff, which I already approved. But now I'm also authorizing it to read my emails. So let's continue. Accept. So this is the auth0 part. So it got my access, my token. OK, nothing very bad. So it can read my email now. So now let's say I also want to list my calendar events. OK, that hasn't finished. So again, it is going to do a step-up authorization, because I only authorized it to read my emails, but not for calendar. So now it asks for a new scope, calendar events. So I'm going to authorize. It's going to. So now it says it already has access. So you have view email and the other stuff, and now I am giving it access to my calendars. So it can read my calendars now, so on and so forth. Like, you can keep doing this for other stuff. So the advantage of step-up authorization, especially in a sensitive environment, is the user is explicitly giving permissions when and where required. So you're not giving blanket permissions using API keys or whatever to the agent. The agent has to ask for permissions each and every time. And you can configure this in different ways. For example, you can configure this in a way that it always asks for this permission each and every time. might be annoying, but there might for some use cases, very critical use cases that might be needed. Or you can say that you need to do this once on first use. You have to give permission, and then the token lives for like a month or whatever, like normal access tokens and stuff. So you can configure it in different ways. But as you may have noticed, with this kind of approach, you are putting the control in the user's hand, the end users, not you, the end user's hand. So the end user has absolute control over this, and they can also go to the your Google dashboard. Google has a dashboard where you can go and remove the permissions that you have given to different apps. So they can do the same for this. They can go to that dashboard, remove whatever permissions they have given for this app, and they don't have to worry about this agent accessing their information again if they don't want to. But if you do the same with API key, you cannot do that. They would have to rely on you to manage all that stuff. So that's kind of the demo. So this is the architecture of the application that I just showed you. It's a LangGraph based application. Has a lot of tools, calendar, Gmail. A fake shopping tool that can do shopping for you. It has an FGA implementation that securely sends documents for a RAG setup, all that. So it's like a reference implementation. If you want to check any of this out, or if you have any of this use case, check this out. And this is a sponsored talk. I'm supposed to talk about this product, which I mentioned a few times. But at Auth0, which is part of Okta, we do have a new product for AI, because we have to ride the hype train as well. But we offer solutions for calling third-party APIs from your AI applications, asynchronous authorizations, doing fine-grained authorization for RAG setups, and so on and so forth. So with that, thank you, and thanks for your time.